Assalamualaikum warahmatullahi wabarakatuh. My name is Nik Syafiq bin Halizi. Metric number is 2018272634. Today I will present about final year project 1. My supervisor is Dr. Wan Ahmad Najmi bin Wan Muhammad. My title of this SYP this year is Optimization of an Industrial Waste Heat Recovery Module through Generative Design Approach. Okay, next. Content in this presentation. One is project summary. Two is introduction or background. Three is literature review. Four is problem statement. Five, project objective. Six, scope and limitation of the project. And the last one is expected result. Okay, next. Project summary. Method of recovering waste heat from a process include catching it and adding it back to the system as an additional energy source. The energy source can be used to generate electrical and mechanical power as well as more heat. A thermoelectric generator module is called TEM was developed based on the conventional thin plate heat sink design for the capture and dissipation of waste heat from an industry. Further improvement to the TM design is to be made targeting a more compact but highly effective heat transfer considering natural convection as the main mechanism for the cooling heat sink. The generative design approach combined with computational fluid dynamic analysis will be applied toward producing the new GM design. Okay, next is introduction or background of the project. First is waste heat is the excess energy that a heat engine releases into the environment as a part of the thermodynamic process through which it transfers heat into usable work. Okay, the second one is waste heat recovery is a heat exchanger that recover energy by transferring heat from high temperature process output to another area of the process, usually for improved efficiency. Waste heat can be obtained from a variety of sources, including steam from cooling tower, hot flue gas from diesel generator, and even waste water from cooling procedure like cooling steel. Okay, next is a thermoelectric generator module. TEM is a solid phase device that uses a phenomena to transform heat fluid different in temperature into electrical energy. Okay, next, the new TEM design will be created using the generative design method in conjunction with computational fluid dynamic analysis. The design goal as well as characteristics like performance or pressure requirement, material manufacturing process, and cost limitation are entered by designer or engineer into generative design tool. Okay, next. Numerical analysis and data structure are used in the fluid mechanics field of computational fluid dynamics (CFD) to study and resolve issues with the fluid flow. Okay, next is since energy intensive machinery can be run at the reduced intensity, this this could result in cheaper maintenance costs and has higher equipment productivity of the product. Okay, next is literature review. The first one is the energy balance across each heat sink surface and through the heat pipe to the copper serve as the foundation for the thermal model developed in this work. It provides for the numerous heat transfer process that take place both inside and outside the heat sink. Okay, the second one is when there is a temperature or airflow, heat will transfer between each component to the heat exchanger, and then all the components of a heat sink send their heat to the copper to the heat pipe. This heat exchanger will be created. Okay, the next one is Fusion 360 is the Autodesk software generative design hit. Get a new product of thermoelectric generator module TEM. The last one is a simulation is done by Fusion 360 for evaluating the shape optimization and the thermal which is heat exchanger of the product. Okay, next. Problem statement of the project is first one is selecting the type of heat sink that according to Fusion 360 software is the best heat conductor for transfer the heat. The second one is the new design as optimizing the product shape after generated design to produce the new and the best result of the design. Okay, next is objective of the project. The first one is to design a new heat sink module with higher effectiveness for industrial waste heat recovery based on generative design approach. The second one is to analyze thermofluid characteristics of the new design using computational fluid dynamics, which is CFD. Okay, next, scope and limitation of the project. The first one is planning for a new concept of for generative design of heat sink that attach to the higher effectiveness for industrial waste heat recovery based on generative design approach. The second is using fusion system create a prototype of heat sink to analyze the thermofluid characteristic of the new design. Okay, next is methodology. They have flowchart, data collection, software design, and model simulation and analysis. Okay, this is flowchart. First, we start. Second, review the current heat sink. Third is provide modeling design using Fusion 360. The next one is assembly the process. The next one is model testing and analysis. That's all. Okay, next is data collection. This is a measurement of the heat sink that we provide. Heat sink have 15 fin. This is size of each part. Okay, next is software. We use Autodesk Fusion 360. Uh, Fusion 360 is a software program created by Autodesk that is used for commercial computer-aided design, computer-aided manufacturing, computer-aided engineering, and print circuit board design. We can collaborate, design in 3D, manage data, make toolpath, and test your design using simulation with Fusion 360. Experts in manufacturing, machining, engineering, and industrial design also favor Fusion 360 as their tool of choice. We also produce a new design TAM using the software. Okay, the next one is design the part using Fusion 360. First, we design heat sink. Heat sink is a component promote heat transfer away from a hot gadget by enlarging the device working surface area and the volume of low temperature fluid that flow through it. It achieves this goal. Okay. Second, we design heat pipe. Heat pipe is a thermal transfer device called heat pipe may move heat and energy hundreds of times more quickly than usually method. A vaporizable liquid is often contained inside a hollow cylindrical heat pipe. Okay, the last one is we design copper, and this copper is mostly used in electrical generator, home, and auto wire because it is very excellent conductivity and ductility. Okay, the next is model simulation and analysis. Heat transfer before and after the simulation are compared in this figure. The heat sink, which is often a metallic component that may be mounted to a device to dissipate heat into the surrounding fluid in order to prevent the device from overheating. It is designed to be attached to a device that emits heat. Geometrically speaking, a heat sink with fin or pin to ensure the surface area for heat transfer is the most effective type of the heat sink. Due to its strong thermal conductivity through the heat pipe, copper is the one of the ideal material to use for the heat sink. Okay, the last one is expected result. There is three conditions that can be applied to the heat transfer flow data for analysis and simulation. The first one is the heat transfer from the heat sink is uniform across its entire surface. The second one is the heat transfer from the copper to heat sink is quick. This demonstrated that the airflow and heat transfer flow are effective. The last one is heat is transferred to all components equally through copper heat pipe and heat sink. The product can function more quickly and smoothly without any issue if the heat transfer flow is equal across all the components. Okay, that's all for me. Thank you.